Ok. Vamos a seguir con el segundo conferencista. El segundo conferencista es Brett Fagan. Él es un ingeniero altamente capacitado con un título de licenciatura en Ingeniería Arquitectónica y una maestría en Ingeniería Civil de la Universidad de Texas. Está registrado como ingeniero estructural profesional en los estados de Texas, Colorado y Florida, y es miembro de la Asociación de Ingenieros Estructurales de Texas, capítulo de Austin. En su rol como Principal Engineer en Allana Buick Bers, encabeza equipos y supervisa la oficina de Austin y en 2019 inauguró la oficina en la Ciudad de México. Su enfoque de especialización se centra en el análisis y la restauración de estructuras, con énfasis en áreas como sistemas de muros, ventanas, techos y una amplia experiencia en investigaciones forenses, lo que lo convierte en un destacado líder en su campo. Por favor, le demos la bienvenida a Brett Fagan.
Thank you for that introduction. Like you said, my name is Brett Fagan, and I'm with Allana Buick Bers. I'm from Austin, Texas. Our company is from Palo Alto, California. I'm lacking a device. There we go. Today we're going to be talking about understanding and design of garden roofs. Let's see here. Some more of my biography. So a little bit about Allana Buick Bers. We're a leading architectural engineering, testing, forensic consulting, and construction management firm. It's a lot of words. Our technical expertise is in building enclosures, HVAC, plumbing, and fire life safety systems. We've been in the business for 35 years and have thousands of successful projects. We do approximately 45% new construction, 40% reconstruction, and 15% forensic work. Currently have about 220 professionals and 21 offices across the United States and in Mexico City. Here's a nice map of all of our locations spreading out across the country. So some of our expertise in roofing and waterproofing, facade systems, window glazing systems, commissioning, mechanical and HVAC systems, fire life safety, solar, LED, and energy conservation, as well as procurement capabilities. So we focus on existing buildings, the envelope, the facade, the mechanical systems, everything once a building is up and running is what we deal with. So jumping into the understanding and design of garden roofs. So when I took on this topic, I quickly learned that there's a lot to talk about with garden roofs. So what we're going to focus on here is more roofing related. So essentially, we want a beneficial garden roof. So that is something that is well designed and well maintained. The benefits include stormwater management. This is something that comes up, especially in my area where we always, in Texas, we have a lot of rain, and so we're always trying to reduce the amount of runoff during our rainstorms into the local sewer systems, drainage. We have a lot of flooding problems. So owners have incentives to control stormwater on their properties. Energy, so it's very commonly known that once you, with a successful garden roof, you can reduce the energy consumption in your building. The garden roof also provides biodiversity and habitat. It provides natural plants for birds and insects. It is meant to address the urban heat island effect. We all know that concrete is hot, and we all enjoy the shade of plants. So obviously, reducing urban heat island is important. And if properly designed, it leads to roof longevity. So all of these things, while there's a big upfront cost to a garden roof, all of these things combined to, in the life cycle of that roof, reduce the overall cost. And of course, there's always aesthetics. So living roofs look great. So here's a local museum with a living roof. Obviously it blends into the natural habitat. You don't even realize how much of a structure is even there. But this is the downside of a garden roof that's not properly installed. So you have here a very elaborately installed and contemplated drainage system underneath a roof deck. So we've got a well-executed set of pans and drain pipes, but that's not what anybody intended when they started the project. So, the goal of the process is to avoid leaks that are preventable. They're always expensive to uncover. The assemblies are really not intended to be disassembled. They're difficult to isolate, and the systems, the roofing membrane systems, are almost always continuously saturated. So here are some of the stakeholders in a design of a garden roof. Obviously, you have the owner who sets out the criteria for the project. You have a facility manager who's responsible for the garden roof and their associated maintenance and operations personnel. So the roof has to be something that they can maintain successfully. On the design side, you have an architect who leads the team, coordinates with all the designers. You have a structural engineer who coordinates the loads and structural safety. Civil engineer would be involved in any stormwater and drainage. Working in conjunction with a mechanical engineer who's also dealing with HVAC and energy modeling. Obviously, then you would have a landscape architect who would design the project, and they're a green roof professional, somebody who's going to deliver the types of plants and growing mediums that are successful on green roofs. And then also a waterproofing or roofing consultant there to look after the integrity of the roof system. And, also included in that would be the manufacturer. You're looking for systems that, given all the criteria, are going to result in something that's successful for the project. So in best practices, you want to provide, structural support. So you've got occupants and plants on the building. You want to focus on quality. You want quality in the products and quality in the installation. Leak prevention is a big part. So even with, a great design and great materials and a great contractor, you still have to have accountability of testing and maintenance on the roof system so you can prevent leaks from occurring. And then avoiding plant loss. So, Mexico City is a great city for garden roofs, right? It's a great environment. Up in Texas, we have garden roofs, and it's a brutal environment for garden roofs. So we see projects that get a lot of fanfare and they get installed, but if you do not actively maintain the plants, replace things when they die, continuously irrigate, the whole system in a few years is going to fall into disrepair, and it's not going to no longer be serving that function. So there are regulations that govern the garden roofs. So in Mexico City, there's a regulation. It's an environmental law that provides the technical specifications for installing garden roofs. ASTM has standards for vegetative roof systems and the membranes that go underneath them. There are other organizations like LEED or green building, other green building standards, decarbonization standards and things like that. There are other incentives out there that you can rely on to guide you in doing your garden roof design. The goal is to mitigate the loss of green space, and for the owner, the goal is to provide an asset that is valuable and in the long term costs, holds their costs in line. So according to the regulations, roofs are generally considered extensive or intensive roofs. I think a lot of you're going to most commonly come into contact with is something like a planter on a roof. They might have a small tree or a large tree. You might come into contact with it at on top of a parking garage, or a below grade garage has a park on top of it, things like that. So extensive really talks about something that is meant to mimic a grass or field, and intensive is something that has shade elements in it. It's a little bit more built up like an amenity. So this talks about some of the weights of it. Obviously, extensive is not as heavy as something that's intensive. So, the weight of the system needs to be taken into account in a saturated state, and with the vegetation fully grown. And I jumped the slide. All right, so intensive living roofs. So this is something, a project in Houston, Texas, where you've got some pretty large trees over a structure. So you've got walkways, and you see the soil built up. And so this is a system that if you have any problems with it, it's going to be very difficult and expensive to evaluate the system and to solve problems with it. So here you have an assembly. So this is a guarded roof, and so this is where some of the definitions get blurred. And at the end of the day, it's up to the design team to take everything into account and provide the project with all the details that are required. So this is a system that's going on a building, and you can see that it has a pretty substantial geogrid and soil going down. At the end of the day, though, it's just going to have a very low grass surface on it. So it's kind of has the weight of an extensive, and the weight of an intensive system with the plants of an extensive system. So, those definitions are kind of relative, and they, you just have to take that into account. But at the end of the day, it's, once this is installed and this dirt is leveled out, how can you make repairs if there's a leak? This is something that, I can't imagine trying to cut into this after the fact to try to solve a problem. So this is the underlying system. So here you have the membrane in progress. And in the US, a lot of the systems get installed when they're on this level of design with hot rubberized asphalt. And so what you're looking at is the fleece reinforcement being applied on top of the roof. On this other section, they already have built up more of the cross-section before that geogrid gets installed. And there's going to be a walkway that comes down the ramp across this slope. So it's a pretty complicated system. It's pretty steep. And it is this is the result of that design process where the owner laid out the requirements and the other entities got involved to make sure that the system is going to be successful. One thing that comes up a lot in green roof designs is this, you see this line of rebar here. So this is where coordination comes in, and this is part of the design process, is when you want to have something like a walkway going across your roof, you need to ensure that you have waterproofing continuity. And so if it's not well thought out on a, you would say a simpler project, they might have a concrete planter on their roof with, 4-inch thick concrete wall. And if they allow the contractor to just cast the deck and cast the walls, then you have a vulnerability if that concrete wall is exposed, because water can just go through the concrete, through your system. So you have a discontinuity between, where this has continuity underneath it. Some, we see a lot where roofs get installed without that continuity, and that's something that needs to be worked out in the design process. So focusing on the waterproofing layer. So looking at your characteristics of what you'd want in a waterproofing layer, you're looking for service life. So, if we're going to double the life of the roof membrane by having a successful project, you're looking at products that already are going to last a while and trying to make them last even longer. So you're looking at the service life of the membrane you're selecting. Hydrostatic pressure is something that needs to be taken into account. A lot of these roofs, we find, always have standing water on them. Even the simplest design, once you have a simple split slab design where you have just a concrete walkway over a protected membrane, it's almost impossible for that to ever really dry out. It's never going to be dry. So you have to always have some level of resistance to hydrostatic pressure. That same thing, since it's always going to be saturated, needs to have be resistant to absorption of water and water vapor diffusion. We've seen studies about the ways in which, roof membranes that we think are watertight and work fine on roofing can, over time, allow water to migrate through the membranes without really having a failure in place. So it's more of a chemical process than an actual physical process of water causing a failure. Like I said, there's continuous immersion. With the plants and the planting design, it's root penetration resistance. So if you see a system where, you have a nice rooftop garden and a rooftop patio and they plant a tree, but it's really just, installed by a landscaper and it's installed and allowed to grow. And a lot of times the trees, we find that they grow too much. They have to be, a tree can be really successful. You might plant a nice, in the US, they might plant a magnolia tree or something like that on a patio. That tree will continue to grow, especially with water, and eventually it's going to have to be cut out and removed and replaced just to keep it in the range for the planting. But root penetration resistance is key, because if it's allowed, the roots will continue to find their way through the system. And then, of course, resistance. So resistance to chemicals and fertilizers and pesticides, all the things that attack, you apply on the plants, we want to have a protection from the, have the membrane be able to protect from attack, and then also resistant to mold, fungus, and biological growth. So all things that can reduce your service life. So, as far as material selection, many times when we're brought into a project after it's started, it's because steps were skipped on the way to installing the waterproofing project. So it's always important to specify the membrane or system to be used. I was working on a project where the architect didn't really go that far with it and used, very general details. And so it caused a lot of problems because, the owner's budget gets set based on what the contractor says the cost is to do that part of the work, but they haven't priced in what really is going to be needed for this part of the project. So it's really important to specify the system to be used. There are many options for design, and they're not all equal. And so, in getting ready for this presentation, you can look at examples of all types of roofing systems being used, and there's a record of many of them being used, successfully to some degree. So there are many options. Also critical to this is manufacturer support. So getting technical services involved, checking for prior projects, and that always sounds good, but it sometimes can be really difficult, especially if you're using a system that is new or not common in your area, right? And then you always want to, determine, the material availability and what type of systems or warranties are available. So, you want to have support for the product. If it's one thing to go and install it, but if you need to go make repairs to it, how easy is it going to be to go execute those repairs? Are those materials that you need going to be available? And then finally, this is something that we talk about on many things in our business, is that every layer counts. So if the underlying layer is not in good shape, putting something on top of it is not going to make it better. It is almost likely going to compound problems. So, if the concrete isn't right, the roof membrane's not going to make it better. If there are problems with the roofing membrane, they're not going to get better when they get covered up by the drainage mat or whatever goes on top of it. So it's paying attention to every layer. A lot of times we see, hey, if the roofer decides to proceed, then he's responsible for what, he decided it was okay to put that roof down. And so it's really important to not proceed over, especially on a garden roof where you can't really get back to these locations very easily and make corrections. So, like I said, in the US, a lot of the projects that get the most design consideration end up with hot rubberized asphalt. So it's a very popular system. It is a monolithic system, so what you're looking at here is a fleece reinforcement. You can see the edge of there's a base ply of hot rubber that went down, and they're getting ready. They've rolled out the reinforcement, and they're getting ready to put a top layer on the system. And then here you can make out that there's a protection layer on top of that hot rubber. And I always, those protection layers always look like the worst roof you've ever seen. It's just they're not lined up very well, and I'm always, have to remind myself that it's just a protection layer. It doesn't have to look great. These are good because of the bond to the concrete deck. So really in a garden roof, anything that's going to be submerged, your strongest ally is a good bond to the concrete deck. That way, if you have, in most instances, a concrete deck is just going to be waterproof on its own, right? I mean, I've seen plenty of instances of that. And so where the concrete deck is going to have problems is where there are holes from drilling something through the deck, or a crack, or some other penetration, drain penetration, or something of that nature, is where you're going to get leaks. In most cases, something like this hot rubber, it's not really, it's nice that it's there and it's providing a function, but if there's a defect in it, it's not really going to affect very much. It might be a pinhole to like a location, but it's not going to travel. And if there is a leak, most likely place to start looking for the problem is immediately above the leak, and not worrying about whether it's, water is flowing laterally from 15 yards away. So going, down the list of popular solutions, then modified bitumen membranes, and this one is being installed in a cold process adhesive. So you have the benefits of a modified bitumen membrane. You have the benefits of a cold process adhesive. So a lot of those adhesives themselves are waterproofing layers. And so it's, and the difference between this and a torch down system is that, torching is more of a process where you can get blisters and voids, and the thought is that by using the adhesive is that you can get better bond, is what we're looking for. So this is, again, is applied directly to the deck. It's going to be covered up with all of the overburden. Then to make this system even better would be to use some sort of coating on top of it. So it would be a belt and suspenders to have, you would put a coating on top of it to eliminate the vulnerability at the laps, is what you're going for. So here we have liquid systems. And liquid systems come in many different forms. This is a PMMA primer going down on a roof deck. There are liquid polyurethanes. There are other chemical formulations. The chemistry can get pretty technical. And so it's important to work closely with the manufacturer about these liquid systems. Looking for manufacturers who have experience in the garden roof arena is important, and trusting products that do have a track record. There are, most of them are fabric reinforced, and again are bonding to the concrete deck. And the benefits of a liquid like this is that it's not hot. You can work on this. This is a pretty small deck on about the 49th floor of a building, and you can walk up the elevator with pails of material and get out on the deck and start installing it. It's very, very user-friendly from that standpoint. Here we have a self-adhered system. So this is going a little further down the food chain. So we've got a peel and stick membrane. And so this is basically like a rubberized asphalt system with a polyethylene film on it, installed over it's a pool deck. And so here we have some concrete walls. So on this project, I didn't get a picture of it but we had all the, before they cast these walls, we had them go through and extend waterproofing underneath all of the walls. And there's a liquid system that goes down, and then this peel and stick is going on top of it. But, these self-adhered systems are acceptable. It also, you're combining the risk and, the cost of these things. And so this is going over a parking garage. And so it's kind of a situation where the owner can live with it. You present them with the cost of a hot rubberized system, and they're like, I don't know about that. And so you come back to this system, and they're okay with it, and it's appropriate. So this is a system that's been used quite a bit, and for over a parking garage, if there's ever a problem, it's not going to be an emergency. And of course, single-ply systems. So single-ply systems get used a lot, mostly in pedestal paver systems, and with, in our area, areas where they're accessible. So even if you have a planter on a roof, most likely there might transition between the single-ply system outside of that planter, and then inside the planter you would have a liquid applied system of some kind. But essentially it's the same concept here. We're digging into an old system, trying to make an assessment, and we've removed the pedestals and the pavers and gotten through. There's a nice, this is not meant to come apart, right? So you've got a beautifully wrapped insulation layer over that you have to cut through, and that's never going to look the same. And then you've got a drainage layer, and then you've got the membrane, and then at the end of the day you've seen about this much of the membrane. So it's really difficult to assess these roofs, to get to see them without tearing everything off. So being with Allana Buick Bers, one thing that we do is a lot of monitoring. And so there's a standard for ASTM. It's a standard practice, and so what that practice does is describe the steps that are commonly used for monitoring. You want to be there seeing these materials installed. Here we are, looking at the drainage mat being applied over that hot rubberized asphalt roof. So monitoring is important here. We're looking at, the moisture content of the concrete. We're looking at voids and defects in the surface. And so these are things that the roofer, does not want to be responsible for. All your liquid membrane in the world isn't going to get into that void and patch it. So it's really important to, have the lines of communication open and be able to get those items corrected before proceeding with the roof installation. Here we are in process. So again, here we're high up in the night, working on a commercial building in Houston, and we've got a liquid system we're installing. And so while in process, we're out there making sure we've got the material coverage that's specified. So you got to take measurements in real time and make sure that everything's going according to plan. And reporting is important, so providing the photos and reports back to the ownership in a timely manner is a key part of the process of quality. At the end of the day, having any sort of moisture content or unexpected leaks is going to be bad for the project and bad for the people involved. So we want to avoid that. Moving along in our project, then testing is critical. So we talked about this before. It's you want, as far as leaks go, you want to test to make sure that you're making good decisions. And so the flood testing is a common, has been common practice for a long time. And so here we have a section of roof, and we've come in and we've created a dam and barricaded off this roof section. There is a ASTM standard it's a standard guide, and so I've spent a little bit too much time with ASTM. So a standard guide is basically a list of steps that you can consider if you want to flood test a roof. It's not a specification. It's not something that is for compliance. So it just basically describes the steps. And one of the things it does say is it's not intended to be used on building roofing systems. So, on a conventional roof, you wouldn't use a flood test because it's not bonded to the deck. If you have a there are other quality steps involved in a roofing system, but if you flood tested a roof and there was a leak, you'd ruin a lot of your product. If you flood test this and there's a leak, it's pretty much going to be isolated to a small location. So here are again, you can divide the roof up into different areas. We've got skylights that are isolated. We've got different drainage areas that are isolated. And that way, if a leak develops, you can, for two things, it makes it easier to fill up the roof area. So you can imagine how long it would take to fill up a gigantic roof plaza deck. Going smaller allows you to do your tests a little faster, and it allows you to move on. If you have a problem in one area versus another, you can just retest a smaller section. So in this type of test, obviously you're looking for leaks below the roof membrane. You can do other things like an infrared scan after it's done and other testing. Essentially, you're measuring, you're monitoring the water level, so making sure you don't lose a lot of water somewhere in your test, and installing drain plugs in all the plumbing to make sure you can actually create the depth of water that you're looking for. So I think here we've got about an inch of water in the area, and you're not looking to create a gigantic load on the building by putting 6 inches of water on the roof. You just really need to cover the roof area, and if there are problems, they would typically show up in that process. So, but here we are, we're back at this roof, and we want to make sure we're making good decisions. So how do we deal with this? And so there is new, current practices to do more electronic leak detection. And so, we're looking for ways to tell if there are problems, especially in liquids where you can simply have a holiday in the coating where, for whatever reason, there's an air bubble or something, a thin spot, anything that can allow water to pass through. So here we have, a standard guide from ASTM and a standard practice. And so the practice is more of a prescriptive step for how you use a low voltage electronic scanning system, and a guide is more of describing these are the things that you would want to do if you're using electronic methods, but both contain really good information. There are some limitations, of course. So applying the electric current at drains and penetrations can be difficult. So there are a variety of different tools available to try to do detail testing. It's really great for the field of the roof, and that can actually cause a lot of problems if it's not done correctly. So you have high voltage, which you may have seen as basically a broom that is electrically charged and grounded, and if it runs over a void or a short in the roof membrane, it would spark, and you would say, oh, well, where that spark is where I have a roof defect. You can get false positives with that if it's not properly calibrated. And then the low voltage system looks like you have like two walking sticks and you're in an area that's got a layer of water on it, and so that's looking for discontinuities in the voltage signal for that test. And so you can find pretty small defects, and you can, like this test, you would say, if you saw that, you might think, is that a problem or not? But with electronic testing, it would say, yes, this is a problem. You would get a result. Same thing with this crack. I don't know if that's an issue or not, but with electronic testing, you can find out. And then I'm not fortunate enough to know where this one came from, but you can see here there's a lot of problems with this installation. And so, it gives you justification to go back and do some more work in those areas. So if you've been involved with an existing roof, you may have been involved with leak chasing. And so this was a project that we worked on, and the indication that we had was we've got a drip here and rusty connection here, right? And the bias that we all have is that, the first time you see something, you think, oh, that just happened. But we don't know that for sure. It could have been 10 years ago when they were building the building and something spilled. We don't know. But we're assuming that this is our leak source. And what we can see here is that we've got some steel stud construction. We've got some walls that used to be continuous, but now somebody's cut a hole in the wall. So this isn't supposed to be open, right? It was finished construction. We're below a roof deck, and you can see that there's all sorts of spray insulation on the slab. So we've got, this is a situation where they're trying to insulate an occupied space below from an unoccupied or an exterior slab. There's a lot here that goes against you figuring out what your problems are. Not to, and this would never show up in a picture, but this is probably about 15 feet above the interior space. So it would be like going above this ceiling and being another 10 feet up to this pipe and trying to figure out, what's going on at that location. So here we are, and it looks great on top. I mean, you've got plants, you've got a nice pool, these trees. So this is our classic intensive green roof. So lots of plants to look at. And so our leak is somewhere in here. So it's right where there's a person standing there, and that's where we kind of think the leak is. So our challenge, with any, my experience with any sort of leak chasing is your first hurdle is buy-in, right? You could go in there and just take a bobcat and scrape everything off tomorrow and have a clean look at everything, but you're negotiating different levels of investigation with the owner and the facility manager because they don't want to do that, right? They want to be able to solve it with the least amount of issues. So, kind of touched on this earlier, but not so much. Green roofs are probably, they involve everybody. They involve every part of your roof, every part of your building. So there's always mechanical systems and irrigation systems, electrical systems, drainage systems. Every element of it's on a building is on a green roof. And so, when we start looking into, okay, well, here's a box. We've got a lot of soil here. We've got some lighting. We've got an irrigation system. We've got this concrete wall to deal with. We're trying to figure out, where is that water coming from? So this is the type of stuff that gets installed. So, it's like, this is really high up on the wall. We're almost at the top of the parapet. You can see there's also sort of low voltage wiring and conduit. And then we've got this wire popping out of the wall for some reason. And where that goes, I don't know. So it's, these types of penetrations are everywhere on the roof, but we don't know, and we have to, can we even test it? Can we get enough water on it to make it leak? And then we dig all the way down, and you can see here, it's, again, the realities of all this is like, we've got drainage mats, and we've got foam, and we've got other layers of filter fabrics. Now that's all been destroyed. And we've got standing water in the bottom of this thing with an oily residue going on. And you think, well, is this the cause of my leak? And it's probably not. You have a system here that's probably watertight, because if it was leaking, it would be leaking now. It'd be leaking today, and it's not leaking today. So, this just kind of shows how saturated these systems are forever. Like this is only this dry because we pumped water out of it. So at the end of this process, we did find some leaks. And so on the other side of this wall, there's a little roof, and the contractor had inadvertently was drilling holes to nail down the insulation and poke some of the holes all the way through the roof deck. And with other leaks happening on the roof, those got wet and leaked inside. So that was, hey, we got a victory. But we got to a point where, going back to buy-in, we think that the roof leak is probably coming from a little bit underneath this patio deck. And at the end of the day, there was never any buy-in from the owner to go any further with that. It was kind of like they throw up their hands and they say, I don't know, and I don't want to tear that out right now because it's March and everybody wants to swim, so they just move on. And then there's the element of this concrete wall, and so you can maybe make out some little periodic little stains here. And so this concrete wall was cast in continuous with the slab. And so it's a discontinuity, and it was something to where with a hose and the time we had on hand, we couldn't ever really isolate it to make it leak. But it's a possibility, and it looks pretty likely. And so the situation, for the owner to say, well, now you have to go in and coat all these walls to make sure, maybe that's the source, maybe it isn't, but it's a possibility, so we need to make sure that that's not going to leak anymore. So I'm very excited because there's a countdown timer that says 25 seconds, and this is my last slide. So thank you. Hope you enjoyed it. Are there any questions?
Thank you, Brett. So, vamos a dar un espacio para preguntas. ¿Hay preguntas para Brett?
Hi, Brett. Yeah, it's in English. What would be, in your opinion, the best system for waterproofing these systems, the garden roof, in your experience?
Thanks for the question. So it really goes back to the sequence that I was talking about. So, we start looking at hot rubberized systems, and then the modified systems with a coating, and then the roof coatings themselves. So it's kind of, a hierarchy of from there. But, at the end of the day, it's like they all can work. They all have different functions. The owners have different priorities. So to say that every roof needs to be like that, steep sloped, hot rubberized asphalt roof isn't the case. And the one roof that we showed, the hot rubberized asphalt roof that was flat was previously a hot rubberized roof that was getting replaced after 40 years. And so those decisions were kind of baked in. We've seen plenty of other roofs where, other systems get used because, there's options. There's options.
Sí, buenos días. En donde se van todos los remates en los perímetros de los pretiles, por lo general los TPO o los PVC, con los movimientos estructurales, sobre todo en edificios, en lo que son amenidades, y con estos calores que está haciendo, hay detalles que se pueden hacer, pero hemos experimentado que sí las membranas sufren esos jalones. En cuestión de TPO y PVC son los más amenos o los más afines con las plantas sustentables. Aquí en México, realmente, ¿cuál sería con estos sistemas constructivos que se pueden colocar? Los TPO y PVC?
So TPO and PVC are similar but different. So from that standpoint, it's we see a lot more PVC in like liner applications than TPO because it's more flexible, right? So TPOs can be pretty stiff. PVCs are softer and more adaptable. The terminations depend on the roof planting design, but for the most part, a standard roof termination would be used.
Okay. Thanks, Brett.
Thank you.
Un aplauso para Brett.